Hi, and welcome to TEMEKO. In this video, we will learn how to solve the forces in truss members by using the method of sections. Also, the concept of zero force member will be explained during this video. Let's get started. If you recall, in the previous video, we learned how to solve the member forces by using the method of joints, in which we draw the free body diagram of joints and solve the forces by using equilibrium equations in order to find the member forces. In some cases, this method is however unnecessarily tedious, whereas the method of sections would be a much lighter method to use. Why is that? Well, the reason is that by using this method of sections, it's possible to determine the wanted member forces more directly than in the method of joints, where we must investigate multiple joints before we can obtain our solution. In the method of sections, the investigated truss is divided into two parts by an imaginary cut from an arbitrary point on the truss. This leads us to have two investigated sections of the truss in which the members are either in tension or in compression. And because of the principle of equilibrium and Newton's third law, the internal forces in the cut members of a truss will also be tensional and compressive forces. Now that you know what kind of method the method of sections is, let's go through the procedure on how this method can be applied. The first thing that we should do is to decide at which point of the investigated truss we should make the two cut sections. We could make this decision based on the members of which member forces we would like to solve, or in which there are at most 3 unknown forces. After this, we should decide which section of the truss we want to investigate. A recommendation for you is to choose the section which would give you the solution sooner. This depends on the unknown support reactions. If it's necessary, then also solve the support reactions by drawing the free body diagram from the whole truss structure and apply the equations of equilibrium. Note that you should do this before drawing the free body diagram of the investigated section if you think this is necessary, because otherwise there are just too many unknowns and you can't obtain a solution. When you are drawing the free body diagram of the investigated section of a truss, keep in mind that unless you are pretty sure about the force's direction, you should draw the unknown force members as tensile forces, like you do in the method of joints. Therefore, the member force which will have a negative scalar will be in compression, whereas the positive scalar will tell us that the member is in tension. Finally, we can obtain the member forces by applying the equation of equilibrium to the investigated section. Let's briefly discuss before we end here about the concept of a zero force member, because understanding this concept will help us to analyze the forces in a member of a truss. So what is a zero force member? We can say that the member which is neither in tension nor in compression when the given specific load is applied on the truss is a zero force member. In other words, a zero force member is a member which under normal loading situation doesn't participate in carrying the load in a truss. We can remove zero force members from the investigated truss after we have recognized them. There are two statements which determine if the member is a zero force member or not. The first statement tells us that if a truss has an unloaded joint to which there are two non-collinear members connected, then both these members are zero force members. Another statement tells us that if 3 members are connected to an unloaded joint of which 2 of the members are collinear, then the third one is a zero force member. Some of you may be thinking, if these zero force members don't usually participate in carrying the applied load in a truss, then why do we need them in the trusses? Well, the purpose of the zero force members in a truss is to offer better stability for the structure by preventing buckling from happening in slender members under compression. Another reason why we use zero force members relates to the cases where the external loading configuration in the truss structure could change. In these cases, zero force members can become load-carrying members. Hopefully, after watching this video, you know how the method of sections differs from the method of joints. You can recognize situations where one method is more suitable than the other, and you also know how to apply the method of sections in order to solve the member forces of a truss. Also, you know the concept of zero force members and why we use them. In the next video, we will discuss how to perform structural analysis for frames and machines. Thanks for watching and have a nice day.